Hi everyone, welcome back to my channel. In today's video, I will try to show you how the add a post or adaptive posting algorithm is working. So as you can see here, if every day I upload a new video on this algorithms. So please try have to have a look on this. So what is the AdaBoost? AdaBoost is ensemble learning techniques that take multiple weak classifiers that just slightly better than random guessing and combine them to form a strong classifier. It does this by focusing more on mistake of the previous classifiers, adjusting this importance in the learning process. So think of it like a team project. So imagine there's a group of students or maybe employees working on a specific problem. Each student might have different strength and weakness. Some might have some might struggle in let's see one area, while the other is perfect. And if they help each other by learning from past mistake, the team as a whole gets stronger. This is how post post or adaptive posting works. So why it's important? Let's see. It's because it turns the weak classifier into a powerful model. It focuses more on hard to classify symbols, refining, and its accuracy. Let's have a look here. For instance, this is how. Assume that you have a data set, and for the data set you will build several classifiers, weak classifiers, and this weak classifiers, is a let's see a specific special decision tree with only one node. You can see, for instance, here I have only one node, and this will be clear with the example. And they have, for instance, they have this weak classifier. Sorry, and they have the second classifier, and the second classifier will try to improve the data the result, and etc. So I have here let's see a diagram. I hope it will try to be to make it easier. So here I have initialized the weights and trained the weak classifier, or let's say learner, and he evaluate the error. Is the error is high, so we have to increase the misclassified weights. Then try to train the weak learner, let's say, or classifier, and do it again until it's the weak classifier is, let's say, performing well. And if it's not too high, the error is not too high, it will ask you, would you like to add, let's see, another classifier or weak classifier? If yes, then we'll try to start, return back to this step. And if not, combine all these weak classifiers to make it a strong classifier, and then predict the final classification. So assume that we have, let's see, this data set here. So let me now zoom in so we can see the data set. So assume that we have spam detection. Imagine you want to classify email as a spam or not a spam, and you have these four emails. The word contains free, it should be spam, and no, it hasn't contains free, it will be not spam. And this is, let's say, only a small data set. It's not a data set, but just to make it simple. And imagine that we need to classify if an email contains a word free, they will classify it as a spam. So what they will do, they will take only one feature here, and let's say, for instance, free. They will see how many samples do we have here? We have four emails, and initializing the weights, they will try to make it all the weights are all the data are having the same weights. So it's important all the emails. Now we will try to build a weight classifier, and which one is has misclassified, we will add a big large weight to this. So in the next time we will try to correctly classify it. So start with the weight, and because here we have four for data, We have 4 weights. So that train the first, let's say, weak classifier. The first classifier. Let's assume that we have contain free. So the contain free, it's predict spam. Now we will see contains free. It will be spam, no, no. This is the, let's see, this is the true label, and this is the 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 prediction. And we see here we have corrected two classified, and here we have missed, let's say, missed two classifiers. And now we will try to calculate the error, then updating the weights. And with updating the weights, it will try to add to update, not to update, to calculate the error with this formula here. And if we get, let's see, error point 4, we will get this formula here. I mean this value. Now, this is, let's say, a weak classifier, and for each classifier, we will try to take only one, let's say, features, because as I said in the beginning, it's only a special decision tree with only one node. Now, let's see, we need, after getting this error, we need to update the weight. If, for instance, the new weight, if it's correctly classified, we will add this e to the power alpha, and this and if it's misclassified, we will add this. And after numerizing and misclassified, we will have a higher weight. So for this here, it's not correctly classified, we will add more weight here, so that the classifier will try to make it, let's see, correctly classified. And after let's see, training several weak classifiers, so it will try to make many weak classifiers. So let's see, 50, 20, it depends on your stuff. And now how to build now a strong classifier. So the final decision is made by combining all these weak classifiers, weighted by the alpha. The alpha is all defined in this example here, in this formula. So let's assume that we have 3 or 4 different classifiers. So for instance, if the classifier 1, if free, it should be spam. If discount, it should be spam. If urgent, it should be spam. Let's see, this, for instance, free, discount, and urgent are the other attributes. For instance, he and he and he. Yeah. And each classifier contributes with its weight. Now, with this formula here, we will try to find to build a strong classifier. Let's say this is example here. For instance, check free. The weight is 0.2, and the prediction, for instance, is spam. The check discount 0.4. It's not spam, and etc. And now we need to calculate this with the help of this formula. We will try to find the final prediction, and see, we have compute the weight, and here we have 0.2 multiplied by 1. So for example, this multiplied by the class label, and this multiplied by the class label, and etc. And the final answer, it's positive 0.1. It's a positive value, so it will be classified as spam. So as a, let's say, a takeaway, the final decision is based on the weight of majority foods. As you can see here, we add the weight multiplied by the class label, and summation all of this with the help of this formula. A weak classifier with high accuracy have a higher influence, of course, because it has more weight. Let's see. And I think this is regarding the theory stuff. I tried to make it simple with this example here. Hopefully it will you will understand it very well. Now I have the code, the Python code. It's here, and you can see. Let me just focus on the stuff that we need. So you have see we have a decision tree, the max depth is 1. So it means only one node. And for the this is for the weak classifier. Now the AdaBoost is a set of weak classifiers. We see here uh, adaptive post classifier is imported for school from sklearn, and here we have estimator. The weak classifiers we have using decision tree. The estimator, number of weak classifiers, and the learning rate, and learning is 1, and the random state, I have mentioned in several videos that if you would like to have the same result with every run, you have to add this random state. Otherwise, you'll have with each run you have different different result, because the split uh, test split, it's randomly splitting. Without this, you will have to, for each time you'll have different X train, Y train, and etc. Now you can see add a boosted fit and add a boosted predict. Finally, we'll have to calculate the accuracy. In the next lesson, I will try to add this as to add it in the classification project. So we will make it is more organized, not just like this. We will use object oriented, and also calculating the accuracy and other metrics. Yeah, I can see. Yeah, this with this data set, IS data set, we got 100%. So as I said, in the next one we'll add it here in this classification project and make it more organized. Thanks for watching, and see you next time.